I'm just getting some kits together for the robotics workshop that I'm doing on Saturday at Living Computers Museum. And I'm testing out some of this stuff. Some of this stuff I'm pre-soldering just because I don't want to go into the logistics of getting this stuff done in the amount of time that I have for the workshop. But I wanted to show you, so first of all, we've got this little voltage regulator that is regulating the voltage from the battery pack and giving it a good 5 volts at 2 amps. So you can see we have a nice green light there on the Crickit. But what I really wanted to show off is the sonar sensor. So I have that working really well. The numbers displaying on the display there are the distance in centimeters away from the sonar sensor right over there. So it doesn't get very good at long range, but you'll see as I put my hand closer, now the numbers start getting into single digits. So I'm about 4 centimeters, 3, 2, 1, and now I'm touching. So of course it's going to go a little crazy when I'm touching it, but yeah, so you can see that sonar sensor is working very well. And that sonar sensor is what's going to be used to do obstacle avoidance with these robot kits. So let me show you the code that's involved with that. That is it. So we have this nice little sonar plug-in over there that gets installed, and all we do is we just tell it what pin we're going to use as the trigger to send out the acoustic ping, and then what pin is used to listen to the echo from that ping. And it's just a simple math calculation, because we know the speed of sound, to figure out how much distance that echo traveled. In this case, I'm doing centimeters because, of course, metric system is awesome and everyone should use it, especially if you're an engineer. So, yep, that's pretty much it. So that is a key part of our obstacle avoiding autonomous robot kit that we'll be doing at Living Computers Museum this Saturday